Good evening to all of you. Hello, I am Saikat Giri. Today we are going to discuss about one of the important topic in chemistry, that is hydrogen bonding. This hydrogen bonding can be important in terms of physical chemistry, in organic chemistry as well as in inorganic chemistry. This part you should have grip with to understand acidic strength, basic strength, intermolecular force of attraction between the molecules. In these things it will be very important, and while discussing the strength of the bond also, it is an important topic. What we are going to read in this chapter? So in part 1 of hydrogen bonding we can read few important parts like how many hydrogen bonding can be formed in a molecule, when hydrogen bonding is formed, and how it works in terms of molecule. What is the definition of hydrogen bonding? Actually, how it is applicable to different molecules. So that we are going to discuss today. Let's start with the definition part of hydrogen bonding. Let's see what is hydrogen bonding. First we will understand what is hydrogen bonding. What is hydrogen bonding? This is our first question, that what is hydrogen bonding? We can say hydrogen bonding is a specific type of attraction force. So we can mark it as H bonding is a specific type of attraction force. So it is a specific type of attraction force. So which type of attraction force, how it works? Let's see. For example, I have taken one atom A connected with hydrogen, and with that another atom connected, that is D. What is A? Let us consider A is the electronegative atom which has more electronegativity in comparison to hydrogen. What may be these electronegative atoms? It may be fluorine, oxygen, nitrogen, sp hybridized carbon, like this is sp hybridized carbon. It may be CCl3, it may be CF3. So carbon tetrachloride, carbon tetrafluoride, FON and sp hybridized carbon. These are the atoms which are responsible for hydrogen bonding. There is a basic rule I follow, that is phone call sp. You also can follow this logic of phone call sp. Phone call sp, it stands for the electronegativity of elements. Fluorine electronegativity near about 4.0, oxygen near about 3.5, nitrogen 3.49, chlorine 3.0, sulfur 2.8 and phosphorus is 2.6. No need of remembering the value. This is only the electronegativity order. You can remember like phone call sp. In that logic you can follow. So these are the atoms that are responsible for hydrogen bonding. Now what is D? What it is doing here? As it is more electronegative, so it will be delta negative. So hydrogen is going to get partially positive charge. As a result, it will become delta positive. So as hydrogen becomes delta positive, it will attract the lone pair from nearer atom. D is the nearer atom and hydrogen is attracting the lone pair of the nearer atom. So this bond is known as hydrogen bond. So what will be the complete definition? We can say that when hydrogen is connected with electronegative atom, it develops partially positive charge. It develops partially positive charge and attracts the lone pair of nearer atom. This interaction is known as hydrogen bonding. So this is the concept of hydrogen bonding. Now the thing is, how many types of hydrogen bonding is there? What are their varieties? That we will discuss in next lecture. But in this lecture, we are going to see how to count hydrogen bonding, which of the hydrogen bonding part is pure, which is impure hydrogen bonding. That part we will look after. See the representation of hydrogen bond, how it is represented. So we are going to read representation of hydrogen bond. Let's see the representation. Let us consider I am taking two water molecules together. Let's find out which type of hydrogen bonding they are making. So H2O plus H2O. These two we are going to check. So in case of H2O plus H2O, you can check HOH. This oxygen has lone pair present. Another H2O molecule HOH. This oxygen has also lone pair present. Now oxygen is more electronegative than hydrogen. As a result, it will develop partial negative charge. It will develop partial positive charge. So this oxygen which is having lone pair, it is going to attracted by this hydrogen that is electron deficient in nature. So they are going to make hydrogen bond in between them. So here hydrogen bond is observed. Here we can say we are observing hydrogen bonding. Another variety we can check. We can check with H2O plus HF molecule. In case of H2O and HF, you can check fluorine is an electronegative atom. It is connected with hydrogen. As it is electronegative, it will develop delta negative and it will develop delta positive charge. Now you have H2O molecule with it. You have H2O molecule connected with it, where oxygen is the atom which has lone pair. So as oxygen has lone pair, they are going to make hydrogen bond in between them. So this is also another example of hydrogen bonding. Let us consider, take water with NH2. We are taking another example, that is water plus NH2. What is happening with water plus NH2 system? Let us think. NH2 you have. This is NH2 and you have water molecule HOH. So oxygen has lone pair, so it is delta negative, this is delta positive. As a result, it will attract the atom which is having lone pair and which is nearby. So they are making hydrogen bonding in between them like this. So in such a way, we can explain hydrogen bonding in different molecules. Hydrogen bond formation tendency, it depends on the electron donating tendency of donor atom. It depends on the electron donating tendency of donor atom, which based on Lewis acidic and basic character. We can say that for hydrogen like atoms, Lewis base character, if we are talking about, we can say that Lewis base character, it is proportional to 1 by electronegativity in the same period. And another logic is this Lewis base character, it is also proportional to 1 by size dependent when in the same group. So you can say that hydrogen bond formation tendency depends on electron donating tendency for donor atom, that is 2 factor dependent if Lewis base character proportional to 1 by electronegativity when elements are in the same period. When they are in the same group, then it is proportional to 1 by size. Now we are going to take few questions depending on hydrogen bonding and we are going to solve. One of the most famous question in IIT JEE Advanced, that is asked like, which of the following form pure hydrogen bonds? It is a very common question. Let's see. Question is, which of the following makes pure hydrogen bonds? So this is the question. Let's take for the first question H2O, and very famous examples are over there. NH3 sometimes asked, sometimes it is asked as for alcohol, it is asked, for ether also it is asked. Let's check one by one. For H2O molecule, for H2O molecule, you can check. In case of water, arrangement is like this. O connected with H connected with another H molecule, and this oxygen has 2 lone pairs. Understand properly, this is a very vital concept. So, another H2O molecule you are taking, another water molecule you take, H, O, H. Another water molecule you have. Now, this oxygen which is having lone pair is going to be attached with this hydrogen molecule. Means it is going to be attached with this hydrogen molecule. So one water molecule is making hydrogen bonding with another water molecule. So this is a pure form of hydrogen bonding. If pure form of hydrogen bonding is there, give a tick, otherwise give a cross. In case of NH3, let's find out. In case of NH3, formation is like nitrogen connected with hydrogen, NH3. ROH we will discuss down. Another NH3 molecule we need, nitrogen connected with hydrogen molecules. Arrangement is like this. This nitrogen has also lone pair of electron. It is going to make hydrogen bonding with this hydrogen. If you discuss for ROR, in case of ROR, which group it is? It is an ether group. How ether group is connected? Let's check out. R connected to O connected to R. This is not hydrogen, this is R group. It may be ethyl, methyl, propyl, butyl, any group. So it cannot make pure form of hydrogen bond, because here hydrogen is not directly connected. Oxygen directly connected to carbon, not hydrogen. ROH you can check. In case of ROH, R connected to oxygen, connected to hydrogen. Another ROH you take. R connected to oxygen, connected to hydrogen. This oxygen has lone pair, this oxygen has also lone pair. Either this oxygen or this oxygen is going to make hydrogen bonding with this. So in this case also you can found pure form of hydrogen bonding. Before going further, there is one more logic depending on this topic. That is, we have discussed about hydrogen bond formation tendency. There is one more form it is asked. Which of the element having highest electron donation tendency? Highest electron donation tendency, we can say that electron donation tendency, that is highest for nitrogen. After nitrogen, oxygen, then fluorine. Why fluorine is least, though it has 3 lone pair of electrons? Because its electronegativity is highest. So because of very high electron, so donation tendency for fluorine is very less. For nitrogen, it is the best donor found. Another questions we are taking after. Take H2O2. In case of H2O2, how is the arrangement? We know H2O2 arranged like this. It has a semi-open book-like structure. Semi-open book-like structure. खुली किताब देखा है ना आपने? एक किताब को अगर आप खोलेंगे ऐसे तो जैसा स्ट्रक्चर दिखेगा एकदम सेम टाइप का स्ट्रक्चर। कैसे? मैं आपको दिखा सकता हूं। ये फॉर्मेट कुछ इस तरीके से दिखता है, सेमी ओपन बुक लाइक स्ट्रक्चर। लेकिन हमारा पॉइंट ऑफ डिस्कशन ये नहीं है। यहां ऑक्सीजन -1, यहां भी -1 में रहता है। दिस टाइप ऑफ बॉन्ड इज कंसिडर्ड एज पेरोक्सी बॉन्ड। यहां एक कॉन्सेप्ट आती है जिसको हम बोलते हैं पेरोक्सी बॉन्ड। अच्छा, ये पेरोक्सी बॉन्ड क्या होता है? पेरोक्सी बॉन्ड मींस oxygen directly connected with oxygen, and in both side it is mandatory there should be electropositive atom. If electropositive atom connected in both the side, where oxygen is connected in between by single bond, then only bond is considered as peroxy bond. F2O2 के बॉन्ड को पेरोक्सी नहीं बोलते। अगर आप F2O2 का बात करो, FOF, इस केस में ये इलेक्ट्रोनेगेटिव है, ये इलेक्ट्रोनेगेटिव है, यहां ऑक्सीजन +1 है। सो दिस इज नॉट पेरोक्सी बॉन्ड। ये पेरोक्सी है ही नहीं, पेरोक्सी ये है। सो हम जिस टॉपिक में डिस्कस कर रहे थे H2O2 को लेके, हम उसी पे कंटिन्यू करते हैं। सो इन केस ऑफ H2O2, व्हाट इज द अरेंजमेंट? विल इट फॉर्म प्योर फॉर्म ऑफ हाइड्रोजन बॉन्ड? यस, इट हैज ऑक्सीजन एटम्स कनेक्टेड। आप अच्छे से देखिए, H2O2 के साथ हम क्या करेंगे, और एक H2O2 को कनेक्ट करेंगे। Another H2O2 is connected. It can make bond with any oxygen. So कोई भी ऑक्सीजन अपना लोन पेयर इस हाइड्रोजन के साथ डोनेट करके पेरोक्सी बॉन्ड बना लेगा। मान लीजिए मैं एसीटोन ले रहा हूं। सारा एग्जांपल्स जरूरी है, ध्यान से एग्जांपल्स को समझते रहिए। आप इस केस में भी देख सकते हैं, यहां ऑक्सीजन हाइड्रोजन के साथ डायरेक्टली कनेक्टेड नहीं है, तो एसीटोन क्या करेगा? एसीटोन कैन नॉट गिव हाइड्रोजन बॉन्डिंग। ये हमारा 6th क्वेश्चन है। दिस इज आवर 6th क्वेश्चन। तो एसीटोन नहीं बनाएगा हाइड्रोजन बॉन्डिंग, मतलब प्योर फॉर्म ऑफ हाइड्रोजन बॉन्डिंग एसीटोन में तो पॉसिबल नहीं है। आगे चलते हैं, हम नेक्स्ट एग्जांपल में चलेंगे। नेक्स्ट एग्जांपल मान लो हम लोग ले लेते हैं CH3CONH2 का। CH3CONH2, तो क्या ये हाइड्रोजन बॉन्डिंग दिखाएगा? और एक एग्जांपल लेंगे CH3COH का। तो हम डिस्कस कर रहे हैं which of the following is going to make हाइड्रोजन बॉन्ड्स। ठीक, सो CH3CONH2 के केस में अगर आप कंसीडर करते हैं तो अच्छे से देखिए, और एक CH3CONH2 कनेक्ट कराइए। CH3CONH2, NH2 का हम कुछ इस तरीके से भी लिख सकते हैं, NH बॉन्ड H। सो यहां नाइट्रोजन के पास लोन पेयर है, ये इस हाइड्रोजन के साथ हाइड्रोजन बॉन्डिंग बना सकता है। देयर इज ए चांस। और क्या पॉसिबिलिटी है? Another possibility is there for hydrogen bonding. We can take CH3NH2. अब CH3NH2 में नोटिस करिए, in CH3NH2, CH3 सिंगल बॉन्ड है, it has lone pair connected with hydrogen। और एक NH2 ले लीजिए, NH2 CH3NH2। Now in this case, either this or this can make hydrogen bonding. So yes, this makes hydrogen bonding. This also makes hydrogen bonding. H2O2 also makes hydrogen bonding. Another example we are taking, that is CH3COOH। एसिटिक एसिड लेके डिस्कस करते हैं। For acetic acid, what can be the arrangement? तो और एक एसिटिक एसिड मॉलिक्यूल आप कनेक्ट करा लीजिए इसके साथ। Another CH3COH molecule is there. Now this oxygen has lone pair This oxygen has lone pair. This oxygen has also lone pair. This oxygen also can make hydrogen bonding with this molecule. So CH3COH में भी hydrogen bonding बनने का चांस है. क्या बेंजीन में hydrogen bonding बनेगा? एक और एग्जांपल लेते हैं, बेंजीन की एग्जांपल ले लीजिए. We are taking example of benzene. Benzene has no lone pair of electron. अगर आप इसका exact structure draw करेंगे तो ये हाइड्रोजन के साथ कनेक्टेड है. यहां कोई भी ऐसा एटम नहीं है जिसमें हाइड्रोजन बॉन्डिंग का चांस है. ऑल आर sp2 हाइब्रिडाइज्ड. सो इस केस में हाइड्रोजन बॉन्डिंग बनने का कोई चांस नहीं है. अच्छा, अगर मैं पायरोल को लेकर डिस्कस करूं, लेट अस कंसीडर आई हैव टेकन दिस कंपाउंड, N is connected. क्या ये हाइड्रोजन बॉन्डिंग बनाएगा? क्या इसके पास हाइड्रोजन बॉन्डिंग बनाने का चांस है? NH अगर मैं ले लेता हूं, it has a lone pair of atoms. So with another pyrrole molecule, if I take, in this case, it is going to make hydrogen bonding with this molecule. So yes, in this case, hydrogen bonding is possible. Here, hydrogen bonding is possible. और कुछ केसेस लेते हैं, कुछ फेमस केसेस लेते हैं. बहुत फेमस एग्जांपल है जिसको हम बोलते हैं बोरिक एसिड. अब जानते हैं आपका हाथ पैर कट जाता है तो हम एक व्हाइट कलर का पाउडर लगाते हैं जिसको बोरिक एसिड बोला जाता है. सो दैट इज H3BO3 नेम्ड एज बोरिक एसिड. इससे और भी बहुत सारे टाइप के क्वेश्चन आते हैं. बहुत बार पूछा जाता है कि बताओ बोरिक एसिड की N फैक्टर क्या आ जाएगा. N फैक्टर क्या होता है? एसिड के लिए उसकी बेसिसिटी होती है, बेस के लिए उसकी एसिडिटी होती है. व्हाट डू यू मीन बाय फॉर एसिड बेसिसिटी? नंबर ऑफ रिप्लेसेबल हाइड्रोजन इज basicity, number of replaceable OH is acidity. So whenever you are taking H3BO3, let us consider H3BO3, it is connecting with water molecule and it forms BOH whole 4 minus plus H plus. ये जो H plus आ रहा है ना, ये वाटर से आता है. ये एक लौता एसिड है जो अपना H plus नहीं देता, दूसरे को फोर्स करता है अपना H plus देने के लिए. So H3BO3 is such an acid which forces another water molecule to donate its lone pair for itself. So in this case we can find out its N factor is 1. तो टॉपिक में तो हम टॉपिक में लौटते हैं. H3BO3 हाइड्रोजन बॉन्डिंग देगा या नहीं देगा? Let's draw the structure for H3BO3. So HO 3OH is connected. In this case 3OH is connected. Another H3BO3 molecule you take, HO, B connected with O, connected with H, another OH. So yes, this is going to make hydrogen bonding with this molecule. So here also hydrogen bonding is possible. In H3BO3, hydrogen bonding can be done. Let us take an example of HCN. Another example we are taking, that is for HCN. What is going to happen for HCN? We are going to check. Question number 13, that is we are going to take HCN molecule. It is connected with another HCN molecule. We know that this nitrogen has lone pair of electron. So this lone pair of electron going to be connected with this hydrogen. So yes, there is a chance of hydrogen bonding. If you take alkyne C triple bond C single bond H single bond H, there is no lone pair of electron, so it is not going to show hydrogen bonding. These are few very famous examples that we have discussed. For example, HCl, will it show hydrogen bonding with itself? No. HCl's hydrogen bonding is not pure. This is delta positive, this is delta negative. With another HCl molecule, it will not make hydrogen bonding. We know that fluorine, oxygen, nitrogen is capable of making hydrogen bonding, but chlorine is not, except it is CCl3. In case of chloral, besides being chlorine is there, hydrogen bonding is formed. Chloral dihydrate is formed. Chloral connected with two OH molecules. This is an exceptional case for hydrogen bonding. Also it happens in case of ninhydrine. Ninhydrine also shows hydrogen bonding. Now in this case you can check, if you are taking 2HCl molecule, it will not make hydrogen bonding with itself. But if you take HCl with water molecule, if you take with water molecule, In that case, this oxygen is going to make hydrogen bonding with H. So in this case it is possible, but with each other it is not possible. So these are some cases of hydrogen bonding. We can say pure HCl do not make hydrogen bonding, whereas HCl with water makes hydrogen bonding. Next topic of discussion is strength of hydrogen bonds. How to decide the strength of hydrogen bond? If donor atom is same, the first logic is we are going to follow. If donor atom same means whatever atom is going to donate its lone pair for hydrogen bonding, if that is same, then strength of hydrogen bonding, then we can say strength of hydrogen bonding, that is proportional to the electronegativity of atom. Whatever atom you are taking, it is directly proportional to its electronegativity. That is the first logic. Let's take an example. For example, I have taken HF connected to water. Another case I am taking that NH3 connected to water. It is asked which is going to have better hydrogen bonding. We know that HF is more electronegative in comparison with NH3. So in this case, you can draw it like F connected to H and H2O molecule you have. So O, H and H. In this case, oxygen is going to have lone pairs. So they are going to make hydrogen bonding with each other. So here donor atom is this, it is going to make hydrogen bonding with this. In case of NH3, you can consider nitrogen connected to 3 hydrogen atoms. And in this case, water molecule is there. Lone pair and lone pair. So it is going to donate its lone pair to hydrogen. So here we can see in both cases water is the donor, and if donor atom is same, strength of hydrogen bonding depends on the electronegativity of atom. Here fluorine is more electronegative than nitrogen. That's why we consider this is a stronger hydrogen bonding in comparison to the first one. Let us take the second logic. If donor atom is different, we are taking different donor atom, then what is the logic? Then strength of hydrogen bond, that is proportional to the donating capacity, we can say, or Lewis basic nature of whom? Of central atom. It depends on Lewis basic nature of central atom. Now what is the order of Lewis basic nature? We know that highest is nitrogen, then oxygen, then fluorine, and down the group it decreases. Fluorine better than chlorine, then bromine, and bromine better than iodine. So this is the order of Lewis basic nature. Highest nitrogen, oxygen, fluorine, chlorine, bromine, iodine. The Lewis basic nature. By this also we can solve the questions. Fluorine connected to hydrogen and another fluorine connected to hydrogen. First question we are going to take. So in this case, hydrogen bonding is done in between fluorine and hydrogen. Another case we are taking OH connected to another OH, whereas this is lone pair, this is lone pair. So in this case, which bond is stronger? Obviously, fluorine bond is stronger than hydrogen. Why? Because here we are following electronegativity difference logic. But you can see in this case, in second case, here you see NH3 and NH3. Here donor atom is same. In this case, what we can say? Here donor atom same. As donor atom same, it is proportional to electronegativity. Oxygen has more electronegativity than nitrogen. As a result, in this case, for this hydrogen bonding, it is better one and it is more strengthened. In this case, you can see what is the donor atom here? ROH and RNH2. These are donor atoms. Here, donor atom is different if donor atom is different, it is proportional to Lewis basic character. Lewis basic character. As a result, in this case, it has better Lewis basic character in comparison to this. Why? Because nitrogen is a better donor than oxygen. So these are the two logics to solve hydrogen bonding. Basically, we follow these two forms. One is which one of the form is more pure, or which one of the following will form pure hydrogen bond. Another logic is what is the strength of hydrogen bond. Now we are going to discuss the last topic, that is extent of hydrogen bonding and how to count them. Let's see. Next topic we are going to discuss, that is extent of hydrogen bonding. We are going to discuss the third part of this topic, that is extent of hydrogen bond. So extent of hydrogen bond depends on two factors. What are they? First one is number of lone pairs. Second one is number of hydrogen present in that molecule. But some anomalies are there. First I am discussing the anomalies. Let's see. If we take nitrogen, in case of nitrogen, only nitrogen, nothing is connected. There is one lone pair, so it makes number of hydrogen bonds. It makes one hydrogen bond. If you take oxygen, oxygen has two lone pairs, it makes two hydrogen bond. If you take fluorine, you can consider that fluorine has three lone pair, it should make three hydrogen bond. No, it makes only one hydrogen bond because of high electronegative nature. If you take chlorine, chlorine has also three lone pair, but chlorine also makes one hydrogen bond because of bigger size. Because of bigger size or large size, you can say. Because of large size. Now let's take few molecules and count how many hydrogen bonding is possible for them. First example we are taking HF. How many hydrogen bonding it can make? You know that fluorine, it can make one hydrogen bond and one hydrogen connected. Total 2 hydrogen bonding it can do. So number of hydrogen bonding is 2. Number of H bonding we are counting. So number of H bonding is 2. What happens for water molecule? In case of water, you can check oxygen connected with 2 hydrogens, 2 bonds, so 4 for octet filling up, 2 more lone pairs. So 1, 2, 2. This is 1, 3, this is 1, 4. So it makes 4 hydrogen bonding. So H2O makes 4 hydrogen bonding. If you take an example of H2O2, for example, you have taken H2O2. How it is arranged? H-O-O-H. 1, 2, 2 lone pairs, 2 lone pairs. Total 4, 1 hydrogen, 1 hydrogen. Total 6. It makes 6 hydrogen bonds. Let us consider. You take H3PO4. In H3PO4, how many hydrogen bonding is possible? Let us draw its structure. P double bond O, OH, OH and OH. In this case, check out 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So 2, 2, 4, 2, 6. 6 lone pairs. 7, 8, 9 and here 1 and 2. Total 11. So 1, 2, 3, 4, 5, 6, 7, 8. 8 lone pairs plus 3 hydrogens. Total 11 hydrogen bonding it forms. 11 number of hydrogen bonding. NH3, nitrogen connected with 3 hydrogens. It is having 1 lone pair. You are taking NH3. So 1, 2, 3, 3 hydrogen, 1 lone pair. Total 4 hydrogen bonding. If you take H3PO3, in case of H3PO3 connected like P double bond O, OH, OH and H. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. Octet is filled up. 1, 2, 3, 4, 5, 6. 6 lone pair and 2 hydrogen. Total it makes 8 hydrogen bonds. So these are the logics to find out number of hydrogen bond. Let us take H2SO4. How many hydrogen bond it makes? Sulfur, double bond O, single bond OH, single bond OH. 1, 2, 3, 4, 1, 2, 3, 4. Each is having 2, 2 lone pair. 1, 2, 3, 4, 5, 6, 7, 8. Total 8 lone pairs are there. So 8 hydrogen bonds. How many hydrogens? 1 and 2. 2 hydrogens. Total 10 hydrogen bonding it is forming. So these are the basic logics to decide hydrogen bond. Let's take the last example of today. We are taking RNH2. For example, RNH2 is taken. How many hydrogen bonding it can make? R single bond N connected to hydrogen, one lone pair. 1, 2 and 3. Total 3 hydrogen bonding can be formed. So today we have discussed, first we have discussed what is hydrogen bonding, when it is formed. Second, we have discussed what are the strength of hydrogen bonding, what are the pure hydrogen bonding formed in which of the molecules, and how to count the number of hydrogen bonding present in the molecule. Next day we will discuss about strength, acidic basic strength, and in case of different groups, group 13, 14, 15, how it affects. Thank you everyone. Please like and subscribe and connected with me. Any confusion, any doubts, please message in the chat box. I will help you with the topic. Let's learn and help people to learn. Thank you everyone.